This video is going to explain how to solve exponential equations, hence the title. Important to know the title to these topics. Okay, so solving exponential equations. So I have 3 exponential equations here, and the instructions are to solve. So I need to solve for x in this case. Now, how do I know if an equation is an exponential equation? Right? We know that if we see an equation like this, oh look, squared. So this is a quadratic. If we have something like this, that's a 1, so this will be linear. Exponential equations will have variables or a variable as their exponent. So that's how we're able to determine whether an equation is exponential. Key is my variable is an exponent. So if I take a look at each one of these, my exponent has a variable. Exponent, variable, 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 variable. So we know that these are exponential equations, okay? Just so that we're on the same page. When I mention base, it is whatever I'm raising a power to, okay? So we know that a can be, a can be a variable or it can be a number, okay? And then we know that this little superscript here we call exponents or power. And lastly here, I took the time to write and list the exponential or exponent properties, okay? Very important to know, very important to memorize and be able to have it there in our toolbox, because it's gonna help us in the long run, okay? So not too difficult to remember, So just to go through it real quick, the first one, if I raise anything to 0 power, it's gonna equal 1. If I raise anything, or let's say if I have something raised to a negative exponent, we talked about this one, we have to bring it down to the denominator if it's in the numerator, okay? So I bring it down, I put 1 over a, and then now my exponent will be positive. Okay, so that's how I'll make a negative exponent positive. Now, if I'm multiplying the exponents like this, in this case, right? I'm multiplying with exponents. I write a on both of them because they must be the same. So if I have, let's say x squared, if I have x squared times x cubed, yeah, I have different exponents, and m, right? That's why I choose different variables. But notice a and a, they're the same, okay? That's very important because we have to know that the base must be the same for us to combine, right? So in this case, if I'm multiplying, I will add my exponents. So I would get x raised to the 5th power, okay? This one we've seen plenty in our class, okay? This is the power to power rule, okay? If I raise something to a power and then raise that to another power, I'm gonna multiply my exponents. In this case, if I have x squared raised to another power, then I will multiply my 2 numbers here. So 2 times 3 would be 6. Okay, lastly, here, if I have two exponents being divided here, then I'm gonna grab the top exponent and subtract it from the bottom exponent, which equals x negative 1, which in turn we can apply this property and say this is actually equal to 1 divided by x to the first power. Now, to the first power, we don't really need to write. If there's nothing there, it's already assumed that there's a 1 there. Okay, so important to know and be very familiar with the exponent properties. If not, this homework is going to be, let's say, annoying. Okay, so my purpose here is to try to get the same base to solve these exponential equations. That is my main target. Get them to be the same base, okay? And I wrote that here on the last property, and this is a property mainly for solving exponential equations, okay? I wrote same base, drop bases, okay? Okay, same base, I can drop the bases. So here's an example. I have a raised to x plus 1 equaling a raised to 2x, okay? I have the same base, they're both a, so I can get rid of them. And all I'm left with is the exponents. So x plus 1, I can bring it down. 2x, I can bring it down. And then once I get it here, it's a simple algebraic equation. Combine like terms and solve for x. Okay, so that is why we're trying to get the same base here, so that we can just drop the bases and then bring the exponents down. Let's take a look at this first one. Okay, I'm looking at these two bases, and I need for my bases to be the same. Well, if I look at my properties, it looks like I'm going to use this first one. Okay, and that is done by saying, well, 9 divided by 8 is what I'm trying to get it to. And if I raise that to the power of 0, right, and I'm just going to rewrite this. I have 9 divided by 8, and this is raised to 3x plus 12. Okay, well, we know that anything raised to the 0 power is 1. Okay, so we're not, just like we see in math all the time, it may look different, but it's the same, right? According to this property, if I raise it to 0 power, it equals 1. I raise it to the 0 power, it equals 1. And that's perfect because I have the same base now. Okay, so I can get rid of those bases. Then I'm just left with the exponents. So it would be 3x plus 12 equals 0. Well, we're going to isolate the x, so I'm going to subtract 12 from both sides. And I'm left with a negative 12 on this side and a 3x. Then I'll divide by 3 both sides. I'm left with x equals a negative 4. For the next one here, again, I need the same base. And usually with these, what I try to do is grab the bigger number and try to get it to look like this, right? Say, can I raise 2 to a certain power to get 64? Well, I can, and I hope you have your calculators there handy, ready, because you will need them. Okay. If you take a look in your calculator, if you raise 2 to the power of 6, that means that it's 2 times 2 times 2 times 2 times 2 times 2. Hopefully that was 6 times. Okay. Then you will get 64. Okay. So if you type this in your calculator, write 2, and then you can hit this little symbol. Okay. And then write 6. This will equal 64. Okay. Like I said, it looks different, but it's the same. And it's what we need, because then I will have a base of 2. Just like the left side. So 2, and I'm just going to rewrite this one. 2 raised to the power of 3x plus 5. Here, 2 raised to the power of 6 is 64. And then that is raised to x minus 7. Now, I have the same base, which is nice. We can drop the base. But before I drop the base, I like to apply this property here first. Okay, so this is power to power. Power to power, looks like this one. So what do we do with the exponents? We multiply. Okay, so that is going to be 6 times that exponent, which is x minus 7. So it's got to multiply all of it, x and negative 7, right? So we're going to distribute there. I'm multiplying those two, and I'm left with 2 raised to the power of 6x minus 42. And then here we haven't done anything on the left side, so we're just rewriting this. Okay, same base. So let's drop that base, and we can set up our algebraic equation here. Again, I'm just rewriting. Once I have the same base, I can just rewrite the exponents here, bring them down, and then it's just a simple case of solving. So I'm going to combine this like term with this like term. Okay, I have to subtract because I'm going across the equal sign. This would be 0. I would be left with a 5 on the left side. 6x minus 3x would be 3x, and minus 42. These two are like terms, so I'm going to combine by adding 42 to both sides. That would be 0. I'm left with 3x equals 47. And last step would be to divide by 3. Okay, so x equals 47 divided by 3. Okay, can't reduce there any further, so that's my final answer. Lastly, this one's a bit different. I have a fraction here, just like here, but this one's gonna be slightly different. Now, when I see stuff like this, I usually I focus in on the denominator there, okay? I know that 27, I know that 3 raised to the power of 3, so 3 cubed is equal to what? 3 times 3 times 3. 3 times 3 is 9, and then 9 times 3 equals 27. Which is nice, because then that's the same base as the base that I have on the left side. Okay, so again, I like looking at the bigger number, focusing on the denominator here, and saying, can I raise 3 to the power of something to get that number? In this case, it would be to the power of 3. Now, I can't just simply write 3 to the power of 3 and close that in, right? Because this equals 27, not 1 divided by 27, okay? So this must be the same as that, which it isn't, sorry. But if I take a look at this property, okay, if I give that my exponent a negative, then I will have to bring it down to the denominator. So all I would have to do here is make that a negative, right? Because if I have 3 raised to the power of negative 3, then I would have to bring that down according to my property. And then now my power is a positive. Okay, so then if I continue, 3 raised to the power of 3 is 27, like we've determined here. Now this would be equal to this. Looks different again, but it's the same. On the left side, I'm just gonna rewrite. Okay, same base, nice. But I'm gonna go ahead and do this property first, okay? That's a power to power. So I multiply my exponents here. So it's gonna be 3, then raised to the power of 3, all, or multiplied to the x minus 3. Okay, and if I distribute here, I'll be left with 3 raised to the negative 3x plus 9. 3, and I haven't done anything on the left side, so I'm just gonna rewrite it. Okay, same base, drop the base, and I'm left with 7x plus 4 equals negative 3x plus 9. Let's solve. Minus 4, these are like terms. Then I'm gonna add 3x and add 3x. Okay, so negative 3x plus 3x is 0. 4 minus 4 is 0. I'm left with 7x plus 3x is 10x equals 9 minus 4 is 5. Now divide by 10 both sides, and I'm left with x equals, right, that just becomes 1. 5 divided by 10, please reduce, which will make it 1 over 2, and that will be my answer.